All right, in this question we're looking for the gravitational field at a certain distance from Mars. They tell you at location A, the field strength is 3.6 meters per second squared. Now remember, gravitational field is little g in physics. Now they want to know what the gravitational field would be if we're 2.5 times that distance away. So I'm going to call the distance to our first one r, and if I increase that distance by 2.5 times, my final location will be 2.5 r. So if you'll recall from earlier tutorials, little g is universal constant times the mass of the attracting planet divided by r squared. That's our relationship that tells us what the gravitational field strength will be at any location. And we can see that it's directly related to mass. So if the mass of the planet doubles, the field strength will double. But for this question, we want to focus on the denominator. And it's telling us that it's inversely related to the distance to the mass, to the center of the mass, squared, the radius squared. That means if I double the radius, 2 squared would be 1/4 the gravitational field strength. If I triple the radius, 3 squared is 9, that'd be 1/9 the gravitational field strength. So we say that the gravitational field strength is related to, or is proportional to, 1/r squared. And in this case, our radius is increasing by 2.5 times. So 2.5 times r, and we have to square it all, gives us a factor of 6.25 r squared. So in other words, my little g will be reduced by a factor of 6.25. So if I take my original gravitational field strength and I divide it by 6.25, I would get my answer to be 0.576 meters per second squared. Now keep in mind, you could simply just calculate it. You could see what happens, you could make up an initial distance and then make it 2.5 times bigger and see what the relationship is between the two. But that's not the intent of this question. The intent is to look at the relationship from the formula and solve it from there.